again, thank you so much for sticking with us through this day. I hope it's been informative and useful. I know I've learned some stuff, which is fantastic. I'm going to close out our presentations with some suggestions, as Mike said, about how to reach this new and growing audience by taking advantage of this increasing popularity of streaming media devices. So let me answer this basic question first, which is, why develop for streaming media devices in the first place, especially if you're not, I guess what you would consider a typical video app, right? I mean, aren't they usually designed for Netflix and HBO Now and Hulu and Amazon Prime, of course? Of course they are, but they actually have so much more to offer. So if you haven't really looked at these devices as a potential launch platform for your game, maybe it's because you haven't seen their sales numbers lately. I mean, streaming media is really, really popular, and streaming media devices obviously simplify the delivery of streaming media to traditional screens, by which I mean TVs. TVs in the living room or the family room or wherever everybody gathers for Game of Thrones night, or when the kids have a sleepover and they're going to watch a scary movie, or wherever you just kick back over your lunch hour when you're working from home. Even my mom has one, and she loves it. So she has a Fire TV, and she's not the only one who loves it, actually. Amazon Fire TV and Fire TV Stick represent two of the biggest reasons that I'm actually here talking about streaming media devices, of course. So Amazon makes two of the most popular devices that are available right now in the market. And so, of course, I want to help game developers leverage this. The things are becoming more widespread, they're more popular, and it just so happens that the hardware, at least in the Fire TV, is also highly game capable. So not only is it a great gaming platform, but it also runs Fire OS, so it's Android based, and this makes it remarkably straightforward, really, really super simple to bring your existing Android game to the hardware. And so why wouldn't you do that and expand your potential reach? So just a couple of last data points if I haven't convinced you. Prime Day this year, which I think was just last week, actually, Amazon sold 2.5 times as many Fire TV devices as we did last year. So in fact, Fire TV Stick was our best-selling Amazon device. And you picture all those customers unboxing this cool new toy, setting it up, pairing the Bluetooth game controller that they got because they heard it plays games too, and then your game is right there, ready for them to install, or maybe not. Oh, wah wah. So, like I said, it's remarkably straightforward to bring your Android game to Fire TV, and at least you can benefit from this rise in the streaming media device popularity. So you can potentially increase the reach to a whole new audience. Now, if you want to maximize your chance for success, there are a few best practices that will definitely help you make the greatest impact. Mostly, they just come down to making smart design choices, especially with respect to the big screen. The biggest screen, actually, the one in the middle of the house, right, as I mentioned. And you may be of two minds here. You may be thinking, well, I really don't want to have to redesign my whole app to run on this different platform, and it sounds like I might have to. But on the other hand, you may be thinking, actually my game pretty much runs in landscape only. I wonder if I'd even have to change anything. And that's really what this session is all about. It's just identifying the types of changes you might conceivably have to make in order to tailor your game to a streaming media device. And not just Fire TV, though, of course. I highly recommend it because it's a powerful and popular choice. And the primary shift in perspective, at least from a game development point of view, is away, 10 feet away, actually. And the reason, of course, is pretty obvious, because 10 feet is the average distance that most people spend or sit away from the television, as opposed to the 1 or 2 foot experience that you might be typical for a mobile device or a desktop. But practically speaking, what does this mean? Well, it means focusing on simplification. It means adjusting your approach to the user interface, if necessary, at least, to make it as simple and efficient as possible. And it means considering larger fonts, maybe, or less text, simply because it's harder to read a lot of text, especially if it's in a small font. So you may be reducing the general amount of static text in your game in general. It means eliminating extra button clicks and navigation, maybe deep menus, because these interfere with the user experience or the simplicity of the user experience. And these aren't actually new ideas, by the way. They're already well-known and considered fundamental, actually, to something called user-centered design. It also means designing the navigation that you do have to be remote-friendly. And by this I mean it's easy for a user to interact and play with your game with a simple candy bar-style remote, for example. And it's funny because here's something game developers have been doing for 35 years, right? Designing for a joystick or a D-pad, maybe with a few extra buttons thrown in. And then accelerometers and touchscreens come along and add a whole new set of inputs to the mix. And it turns out, for streaming media devices at least, the old ways still offer a lot of utility and value. And in fact, they haven't been completely forgotten. They've actually evolved a little, and they include things like dedicated navigation buttons, standardized over Android, or maybe media buttons that allow you to do typical media type functions like fast forward or play, pause, rewind, that kind of thing. It's good actually to avoid overriding those functions simply because you don't want to detract from the intuitive usage. You don't want to confuse the user if possible. User-centered design also means anticipating user interaction in order to minimize the amount of work they have to do. So if you expect, or you know, for instance, that most people buy one item and then return directly to the game, maybe you pre-select the continue button after they make a purchase. Make sure that the left, right, up, down inputs move the highlighted selection in a logical way. So don't ever force the player down a navigation path that they can't escape, which goes hand in hand with that. And this is actually not as far-fetched as it sounds, because I've seen lots of games that try to be smart about this, do it algorithmically, and they look at what's physically left, to the left of the current selection, and then how do I move the user to that item, what do they have to press in order to get there, and then they find out that there's an error in their algorithm, and once you move to that spot, you can't move to any other items on the screen. Obviously, with touch, or even with a mouse on a PC, this is not an issue because the user can directly click on where they want to go, but this can be a problem, be a little tricky on a streaming media device where you're talking about D-pad navigation. So these are the issues to keep in mind as you move your game from mobile to desktop, to mobile or desktop to a streaming media device. And chances are, as I mentioned, if your game runs in landscape orientation, it'll probably work just fine on television, provided that you take a page from the old school games and make sure to provide clear button states showing selected, deselected, enabled, disabled, etc. You provide easy up, down, right, left UI navigation that you can navigate with a simple D-pad kind of interface. And if you support standard Android back home navigation, or at the very least, provide some kind of clear indication of how to move between screens. Okay, so moving on, let's talk about TV resolution and what that means for your game as you migrate it from mobile. The good news, on Fire TV at least, is that you probably don't have to do anything special. At least you don't have to do anything special to support the native resolution that's displayed on most televisions. You can follow standard Android programming practices with respect to screen density, resources, and the OS, that is the Fire OS system, will automatically handle the rest. In fact, I recommend that you simply build everything for 1080p, which in Android would be indicated by resource type of XHDPI, because the Fire TV will actually automatically downscale to 720p or 480p as required by the output hardware, whatever TV you've got connected to the device. Now, in other Android-based TV platforms, you may have to provide specialized resources in resolutions other than 1080p, since downscaling may not be automatically available. But Android makes this pretty easy. I mean, this is actually one of the nice features of the way Android handles resources in general. So you can create different layouts and set up different drawables as necessary for each target. And you can get more information about all these approaches at the Android developer resources at bit.ly/android-screens. Of course, orientation is another aspect of the device display that may be important to your game, and I've already mentioned that if it runs in landscape mode, it may simply work without changes. If your game mixes landscape and portrait mode, however, or maybe it has functionality that only happens when the device changes orientation, then changes may be required, or at least you should verify that it doesn't break if the orientation never changes, because on a television, chances are the orientation will never change. You can also query the current orientation, of course, and on Fire TV, these are the values that you'll get back. Two other quick points I'd like to mention with respect to TV displays and migrating. First is the idea of overscan, and this is the physical space that TV hardware manufacturers reserve around the outside of the displayable area of a TV screen. And it's something you should be aware of when you're targeting streaming media devices, because this space can exist on TVs of any size, and it limits the area in which your game can actually render its UI. So I recommend that you just keep all your critical UI elements inside the center 90% of the display. Just avoid that 5% border along the outside, just in case. Keep your stuff in the safe zone, and that way you reduce the likelihood of encountering any issues due to overscan. Second, you should be aware that TVs tend to display colors differently than most mobile devices and tablets. TV screens typically have a much higher contrast, so colors will tend to appear brighter, more vibrant, just more highly saturated. So the color gamut of TVs is also coincidentally reduced, which is just another way of saying that TVs usually can't display as many colors as mobile devices. And cool colors like blue or gray or purple, these definitely work better than warmer colors like orange or red, which have a tendency to bleed across the screen. So a good rule of thumb is just avoid oversaturated colors. Basically, if you keep your RGB values below 235 and you avoid broad areas of white, bright white, or off-white. Okay, so we've got some ideas about how to approach UI. We know a little bit about the 10-foot experience, and we've seen some specific examples of how TV displays physically differ from mobile and desktop. What if we find that our game actually does need some adjustment? Are we doomed to creating multiple builds targeting all these various platforms? Well, not necessarily. We can use some techniques that have been explored in depth in the world of web development, which is namely responsive design. So these techniques allow us to release just a single executable derived from a single code base that will then work seamlessly across multiple target devices. So for the most part, responsive design comes down to one or two things, primarily screen resolution and size, which we've covered at length already. So the responsive part comes in when we want our game to dynamically choose and adjust according to the capabilities of the device where it's actually currently running right now. And that is, rather than obviously hard coding some resolution at for a specific target, we create our game to adjust on the fly based on the hardware that it detects. And this isn't actually as bad as it sounds, because we don't actually have to program for every resolution. We can actually use aspect ratios instead. How is this any better, you ask? And you'd be right to ask that. But it's better because screens of widely varying resolution may actually share the same proportions, which is all we're talking about when we discuss aspect ratios. So that means that the width and the height are relatively the same when you compare different screens. That means that there are potentially far fewer sizes to support. We can simply target each major aspect ratio since most resolutions will be scaled up or down versions of that. So you can take this as this work in progress as an example. This game, which is developed in Unity, is designed to support multiple aspect ratios, as indicated by the colored rectangles on the outside. And it's a simple matter for us to detect at runtime the physical size of the viewport and then zoom in or out of the scene to scale the game display appropriately. I mean, it's simple because, there's math involved, but it turns out that computers, even streaming media devices, are actually pretty good at math. So we can make our game use responsive game design essentially in 2 lines of code. And frameworks like Unity make it super easy to test. So we can play the game at whatever aspect ratio we want or the screen resolution we want. We can verify that it adjusts its viewport appropriately and even have it change the size or position of certain UI elements to account for different screen layouts. So this is just a quick loop demonstrating how easy it is to pull down that menu, select the resolution we want, and see how it looks. Another aspect of making your game responsive is dealing with user input. So I already mentioned the importance of clear UI and user-centered design and how supporting a simple controller might exercise a few muscles you haven't used in a while, design muscles. Well, what happens when you want to move from a mobile touch interface to a D-pad remote interface and keep the same code base? This is a slightly different problem. And I won't sugarcoat it or gloss over it with hand-wavy, no big deal, or super simple, or don't worry about it, because it's not necessarily super simple. Designing a game to work well with radically different input methods is actually a non-trivial exercise. And frankly, it may be the hardest part of migration to a streaming media device. It's not impossible, though, either. I've seen it done really well, especially when game developers take advantage of something like a Bluetooth controller. Often, touch interfaces have evolved in order to mimic dual-stick controllers, for instance. So in those cases, the change is actually super simple. It actually is simple. It's almost trivial. Regardless of the input method, though, if it differs by device, the least you can do is to tailor your help screens and your tutorials accordingly. Your players will definitely thank you. Specifically, they'll thank you with their time and attention, since they will appreciate a UI that applies to the device that they're actually using. Finally, make an effort to maintain that connection that you've established with your players and customers, because you can take advantage of the interaction model that is built into streaming media devices, and that is, I'm referring to the way that users view streaming media and receive notifications. You can use that to your advantage to boost awareness of your app and the engagement in your game. You can also connect your app to other devices for rich second screen experiences. So Fire TV, as an example, uses the standard Android notification mechanism, which means that you can present these heads-up or high-priority notifications that appear on screen and then fade away after a few seconds. Super simple. I hate to keep harping on that. Some of this stuff really is super simple. Multiple notifications, if you happen to generate them at the same time, are going to be displayed in the order in which they are invoked, which means one after the other. And it seems like a small thing, but this is actually a great way to keep players informed of key actions or activity that's happening in your game. And it feels very natural to the streaming media experience. You can also take advantage of Amazon Fling, which is an SDK for sending audio and video and images to a Fire TV device or Fire TV stick device from apps on iOS or Android or Fire OS, of course. And it allows playback control and a synced experience if you want to provide some kind of second screen type interface. And it also supports remote install, which allows users to remotely find and trigger Fire TV installation of apps. Unity support for smart game controllers is also included, which provides for remote control from a mobile device, which is often ideal for games and other social type experiences. And then we have Dial, which is kind of what drives that remote discovery. This is the discovery and launch protocol. It's an open protocol that enables your Fire TV app to be discoverable and launchable from another device on the same network. So this is not the same as screencasting or mirroring. It's a protocol to enable apps on a second screen device, like a mobile phone or tablet, to actually find and launch an app living on the Fire TV device, which is kind of cool. Oh, there's an animation. Oh, yeah. And there's an arrow. Perfect. And that's it, really. I mean, so where do we go from here? What if you have a game and you want to dip your toe in the streaming media device waters? Well, first step, get a Fire TV. They're cheap, they're super powerful, they're really nice. Sideload your app, give it a try. Check out the remote action, see how it works with a simple candy bar remote. You can also try it with a game controller. And then just be on the lookout for any weird color issues or gamut problems, overscan issues. But then planning for the future, just keep that 10-foot experience in mind when you're designing your app or game. Think about responsive design so that you can reduce the actual amount of work you have to do. You can release from a single code base. And also think about aspect ratios instead of resolutions. That way you won't be overwhelmed by the number of different resolutions you might have to support. Keep in mind that you're going to be dealing with multiple input methods. So maybe you're using touch or gestural input on a mobile device, but on Fire TV, obviously, you're going to be limited to more joystick type controls. And then also consider using Amazon Fling or Dial to enable second screen experience, which I think is going to be even more important this year than it was last year. That's it. I hope it was a little bit informative, and please, I just want to reiterate one more time that we have a survey that we'd like you to fill out, and I'm sure Mike will talk more about that when he comes up. Thanks very much.